Good morning, everyone. My name is Siritip and judging from my quite long last name there, I'm sure you would know that I'm from Bangkok, Thailand. Um, okay, so so first, let me introduce myself a little bit. Um, I actually graduated my bachelor's degree in Thailand, learning architectural design, but I pursue my master's degree in sustainable design. So my master's is more on the research side of it. I practiced in the States for a while and then went back to Hong Kong. And then I came back to Thailand after that to set up a design plus consulting firm with my husband, focusing especially on doing sustainable design. Okay, so with my work, I'm actually wearing two hats. On the one hand, I work as a designer, so it's more on architect. And on the other hand, I also work as a sustainable design consultant, meaning we provide consulting for project owners, developers, or even architectural firms who would like to maybe pursue some green design rating system, and we help them reach that goal. When we do that, I think we could separate these two tasks into two things, as the way I see a lot of people perceive it. One hand, as architects, we deal a lot with spatial design. We design a space. But once that space needs to comply with green building requirements, there's another thing that has to be added on top of your design considerations or design criteria. That would be green building requirements. And in my experience as I've been working so far, these two things, these two criteria, people see it as a really two separate topic. Architects or designers, we wanted to still do what we do best. That is designing, spatial design. We have functional aesthetics consideration. We also have economic considerations. But when green building requirements has to be added on top, sometimes we feel that it's an additional task that we have to work on. It's quite a tedious task. But actually, what I would like to share with you today is that, to me, I don't think these two are a separate issue. It's kind of overlapping. So let me walk you through why I think these spatial design and green building requirements are actually overlapping. So that leads me to my topic today. I call it spatial experience and green building, sensing the indoor environmental quality. So first, let me talk a little bit about what I mean when I say spatial experience. Spatial experience or experiencing space, to me, I think it is more on how human not just perceive the space, but how they actually use or dwell in a space, meaning there is time and considerations there. It's not the wow factor the moment you walk into a great building, but it's actually the factor when you actually stay there for a longer time to function. For example, if it's an office building, you think it looks really nice, but what happens to you if you sit there and work for 8 hours throughout the day or throughout seasonal changes throughout the year? How would that make you feel? Or if it's this room here, if you have to sit here for until this evening or probably late night as today, how does it make you feel? What are the factors contributing to experiencing that space? So you'll see that there is one factor related here, that is time. Experiencing space or using a space is related to the time factor. Secondly, green building. Green building is quite a big word, probably smaller than the term sustainable design, which is a little bit larger. But with green building, we actually have a standard framework of how people look at green building or what are their standard requirements. And with green building, we know that we're doing good things for the environment, correct? These are the 4 general categories that people use when they define or putting in requirements for green building. I think you might have already known. You have the site aspects, let's say how much areas you have in green open space, any transportation related to that. If you commute less, that means you're impacting the space, impacting the environment less. Secondly, water. If you save on water, that means you're doing good for the water resources. Energy, this is the most topic that people talk about when we talk about green building. Can you use less energy, or maybe checking for opportunities for renewable energy? Materials, even more basic, we talk about it every day. How can we select materials or use smart use of materials that impact the environment less? These 4 categories are more related to life cycle of the resources, natural resources, or energy. But actually, there's one topic missing from here. It is included in green building rating system, but to me, I feel that this topic is talked least in green building. And even though it reflects in research, there is fewer research on this topic, and that is indoor environmental quality. What do I mean by this? Indoor environmental quality, it is generally defined as the quality of the indoor environment. How would people feel in the indoor environment that they're impacting people? Talked about least, but to me it is actually the only green design building category that relates directly to you, meaning users of the environment. We talk less about impacting the environment, but we talk more about the human factor of living or dwelling in a space or in a building with this term, indoor environmental quality. So, let's see. I'm using some examples from the recognized green building rating systems, and you'll see how they categorize indoor environmental quality in different green building systems. I have Greenmark from Singapore. I have LEED, Leadership in Energy and Environmental Design from the United States, which is quite a popular rating system. I also put in from CASB, which is Japanese green building rating system. And I may not know as much as you who are from Japan, but all these, you'll see that these are the ways that they categorize indoor environmental quality. And you'll see that even though some are named differently, there are overlappings. For example, for CASB, we have sonic environment, thermal comfort, lighting and illumination, and air quality. All these overlappings, if you look at it in terms of green building requirements, you'll see that there are many. But if you think in a more of the terminology that is related to how human or how we feel or we sense the space, I think we will look at it a little bit differently. So first, let's look at daylight. I would be using examples from green building rating system to tell you or share with you how these frameworks are defining how designers should be designing with these items. So for LEED, they said that all the space that we occupy or we spend a lot of time in should be daylit. And you get score by providing more daylight in the space. And if you look, there are many technical terms here that I'm not going to describe. But for example, they talk about 100 lux to 5400 lux. That's the light level that we should have. And they ask us to show them that we have enough daylight under clear sky condition in the morning and in the afternoon time. And to prevent glare, we should be providing glare control device. And they ask us to show them by demonstrating through calculations, simulation, or actual measurement. But actually, when you're designing that, sometimes I see that people design it and trying to get the score, or sometimes architects just don't recognize it at all. They just bring the consultant the space. The consultant tests the space, whether it passed. If it doesn't pass, then they don't earn score. But I want us to rethink the way we look at daylighting design. If we don't think of it as an environmental factor, but we think of it as to how human beings perceive daylight, how we sense the presence of daylight in a space, we might look at it differently and probably we will design differently. So let me show you this example. This is a really famous building, but let's try to look at it not from the first impression of how the space looks like, but try to sense it in terms of how you feel the presence of daylight in that space. This Mount Angel Library is very famous for a really smart daylighting design, designing with the geometry of daylight. And this is by Alvar Aalto. He designs it really, really cleverly so that all the readers at this, you'll see the bookshelves here, and you'll see some reading space. All these readers here, they will not see direct sunlight. They will only receive diffuse daylight for their reading comfortably all day. This is quite a complex thinking process, but executed in a really simple design. This is the design that I would say quite smart, executed simply. But if we look at a more simpler space as to how we perceive daylight, like this picture, if we don't judge it by its aesthetic, but instead judging it by sensing daylight presence in the space, you don't even see a light source in that space. We don't see a window. But we somehow feel that there's daylight coming in. You see the liveliness of daylighting presence in this space. I think by human nature, and this has been researched, we prefer daylight to electric light sources. We know that it renders color very nicely. It gives you details of the things that you see. What if I change this source of daylight in this space into all electric lights? And I'm trying so hard to match daylight properties. How would this space, how would you sense, how would you feel that this space looks like? So, to summarize on daylight, let's try to look at it in how you would experience, how you would dwell in such a space with daylight. This is the same as green building requirement in LEED, as I talked before. Focusing at how users or the so-called dwellers would feel in a space. And actually, these green building rating systems, they're just using numbers, using quantitative factors to point to a more qualitative essence of the space. And as I said, experiencing the space means it takes time. And with time, daylight has movement. So I call it kinetics of daylight. Once you design a space, it's not just a single shot, but it's actually an animation of how people would feel the presence of the space. But before the building is constructed, how could we envision how that space would perform? Is there a way to do that? I leave this question with you. Next item, when they talk about indoor environmental quality, there's actually a topic related to view. CASB says that we should have a perceived spaciousness and access to view for office building. And with the ceiling height, at least 2.5 meters, so you'll see that there are some dimensions of space related here. And says that the space should have windows to provide our occupant with what they call sufficient awareness of views. This is what CASB from Japan said. But let's look at LEED. LEED said that 90% of building users, or they said building occupants, should have a direct line of sight to what's happening outside, or they call to the outdoor environment. Between the desk height, up into 2.3 meter high. This is related to how people should be designing a space. But if we re-look at it, rethink about it from a different perspective, from a human point of view, why do we want view in our space? This room does not have view, obviously, but in general, for some other functional usage, why do we love views? It's also human nature. We want to know what's going on outside. And when we want to know what's going on outside, that means we should be punching a window at the eye level of the users who are going to want to know what's happening outside. But strangely, those green building rating systems that I talk about did not mention what kind of view should one see. They just said that the building or building users need to have a view, but what kind of view? Right now, LEED from the States actually gives you extra score. If you have a view to greeneries, if you have a view to human activities, or if you have a view to what they called object. Never clearly define what an object should be seen. So if we only follow green building requirements, but without thinking about human factor, we might be executing the building differently. But once we take a look back onto how humans sense the view, we might be designing it differently. You might be having an exotic view outside like that. That's pretty hard to find for a typical site that we get these days for designers. But with this very, very simple openings. We have the view. If we look at it from a sense of view, that if you dwell in this space for a long time, this is also pleasant to live in or to dwell in. So I think that's the essence of looking at it in a view factor. So if we experience the view, comparing it to green building requirement, there's no difference. But let us rethink of what do these dwellers want to see? What kind of view? What should they see? And how should they see? Or how would you design that they see such views? There's also kinetics of view. If time is integrated into this design. So I would end this topic related to human vision or seeing by the quote from the book that I like. It's a technical book. So let me reread again. It is delightful when qualitative characteristics of these sites are what one enjoys as appropriate to the moment and activity. To design delightful visual environment, one must first understand vision, how we see, perception, what we see, and what we want to see in various spaces and for various activity. And that is the nature of a delightful, luminous environment by William M.C. Lamb. So, let me take you to another different topic, thermal comfort. I don't really know how to put a logo on this. It's really conceptual. So, let's see. I take this from Thailand's green building rating system, which is called TREES. Sounds really green. Thai's rating of energy and environmental sustainability. Actually, the requirement, I find they are quite similar across green building rating systems from different countries. They said, designing the conditioned and unconditioned area to have the temperature and relative humidity to meet a certain standard. In this case, ASHRAE. So it's the American Heating Refrigerating Association. They provide you an option for natural ventilation, but also should be following the standards. And we can see that when you talk about thermal comfort, usually designers just said that it's not my job. We just pass it to the engineers. They have their responsibility to design the thermal and relative humidity to follow the standards so that people can live in a comfort zone. Let's take a step back and look at the space in terms of how we feel, how we sense the space through our touch or through your skins. Because that is the basic of how we actually sense it thermally. In theory, there's a certain set of temperature and relative humidity that human would feel there in comfort. And that is set in a standard. But does that always apply? Let's take a look at this space. I would like you to imagine that you look at this space thermally, thermal only. How would you sense it if you actually enter that space? How would you feel? Would you feel warm or cold? I think this varies differently because none of us has ever been there. So just judging from this photo, what I can extract from this photo is that it might look a little bit warm, but it's not hot. But I feel that the outside would actually get quite hot and dry. But is there any indicators from this photo that you can extract the thermal sensation out of this or not? This is the African Children's Library by BC Architects. And I love this picture because it implies what is happening outside and what the space inside can give the users the feeling of how they could dwell or use that space. Next one. This is Green School in Bali, Indonesia. I'm not sure, but somehow it might be judging from the architectural or materials or something that you feel that the outside environment is different from the previous photo that we saw. And we know that if it's Indonesia, it's going to be hot and humid, similar to my country. But somehow we feel that these students here, they are learning in shade. It is quite shaded. At this moment, you don't see any direct or harsh sunlight penetration. So it feels like a comfy learning environment to learn if they have to spend a long time in there. Another photo. I'm trying to show you different photos from various and different locations to try to sense it in terms of thermal sensation. I'm not sure how the climate in French Guiana would be, but judging from this shading pattern, and you check what's happening outside, some thermal sensation occurs when you see this picture, even though we're not sure how hot it's going to get if you actually go there. But by some of these indicators, it actually gives us some thermal sensation of pleasant. Next one. This one is the International School of Hout Bay. I love this design, but if you only focus at thermal sensation that occurs, if you imagine that you would enter that space, probably, I'm not sure. Could be because you might have the air conditioning system or the heater installed in such a space. So we can't really be sure how that space is performing. So I'd like to summarize experiencing thermally and green building requirement is that human comfort sensation, by theory, comfort zone of human is in a certain limit and is the same. But how about the sensation that people feel? Is there any seasonal or climate characteristics impact on your comfort or not? And if you look at vernacular examples of these architecture, you see that there is some specificity in the context that is different, or there is an indicator of the climate or the locality in that architectural design. Is there a way to design the space to enhance the dweller's thermal experience? And I don't think this occurs only to interior design, but it actually happens since the layout, massing configurations, and building skins. So, I'd like to end with a quote from Lisa Hechong. Looking at a photograph of a place, we're limited to purely visual clues about its thermal qualities. Yet we can still perceive it to be a warm or cool place, thermally pleasant or unpleasant. With our current technology, the temperature of a place need not be associated with the form of the building or materials used or the region where it is located. But how unsatisfying is this disassociation of warmth or coolness from all our other senses? Next, thermal comfort control is another topic that they give you score in green building. For LEED, they said that each building occupant, at least 50%, should be able to control their own thermal comfort. Let's say if it gets too cold, they have to be able to adjust the thermostat. If it gets too warm, similarly. Or they could also use open windows. Let's look at this space. The designer's name is not even listed when I check out this space. But I love it when we feel that there is an open window. If you're in this photo, take out all other design, but think about how comfortable you would be if you wanted to sit in that corner and having that open window outside. And how about this photo? Does it show any different localities? Shows the opening to the outside. So you don't just have a view out, but you can open out to that view. That makes a difference. There's more to vision. There are other sensations that come into play. So I'd like to end this topic with an article. This is an article not really talking about architectural technicality, but talks about just how an open window conveys more than just air. It conveys other social senses as well. I may not have time to read along, but let me read from the second paragraph. It's a sad state of affairs, not just for the possibility of architecture or the ecological corner developers are painting themselves into a glass office, dependent on energy-guzzling air conditioning, continue to proliferate. Next, acoustic. You'll see that I talk about the factors that designers associate themselves to quite a lot, and then at lower and lower and lower considerations, acoustic. Caspi said meeting the requirement for 1, 2, 3, and 4, you have the background noise, equipment noise, sound insulation, and absorption. And for LEED, strangely, typical LEED does not have acoustic topic in the green building requirements. This requirement only occur if you wanted to do school. So acoustic is not really mandated. And also in my country, acoustic is not really regulated except only for some building types. So that's why we don't really associate ourselves with acoustic. They talk about how you should be using materials, how we should be limiting the background noise. And sometimes with acoustic, we leave it also to the engineers. But what about our role as designers? If we look at it from a different perspective, as a human, hearing. So looking back at this very same picture that I used before, but what if we, this time, only sense it acoustically? So if you enter that space, if you yell or if you talk to one another, how would that sound? Or if you were a designer of that space, how would you want the sound to be reflected? Do you want it to be a lively space? Or do you want it to be quite a peaceful space? These are all in designers' hands. We can do that. Same thing goes here. If we read, we have to read there for a long time. If people talk, as a library, do you want it to be quite a quiet place or not? So, hearing and green building. I think it is basic as we don't have to even read green building requirements, but think about a human factor. What do we want to hear? What do users want to hear? That sound has to be enhanced. What they don't want to hear has to be blocked. And this is not only the responsibility of interior designers. It can be designed right from the layout, building massing, building skin, and materials. Next one, indoor air quality. This is the last item that I'm going to talk about for the green building requirements. And this is also least talked about because we think that fresh air here is in the hands of the engineers. And for the low toxic materials, this is done by selecting materials that emit less toxic in paints and coatings, adhesives and sealants, the use of composite woods, or some of the floorings like the carpet floor. All these are to mandate what products you should be selecting. But if we take a step back, look at it in terms of human sense, smell. I know that usually we don't really associate ourselves to this. If we look at this space, the first thing that comes to mind is visual, but not smell. But how would you envision, if you walk into a space, how do you want the space to be like? For this space, it seems quite good ventilation, but you'll never know unless you actually enter that space. But how can designer impact such a space? How do you want it to be like? And there is something that even for human we cannot smell, but it actually impacts your health already. Let's say if the floors there or if the walls there are painted with some of the paints that actually emit some toxic. So that guy and his baby would actually smell it inside. And by not knowing, it actually is the category that impacts your health the most. But quite less obvious when you experience or use the space. What about this space? How would you feel that the air in this space is like? Is the air movement good or not? Is the air stuffy? Or if you are in this room, once you sit here for 8 hours, how do you feel that the air quality is like? That is in the hand of the designer. So least perceived, but it actually impacts your health. And designing is not only by just selecting products that pass the requirements. And there is some climate specificity relates to temperature and humidity that impacts how you would sense the space through your nose. With all these being said, I wanted to summarize by these following slides. Integration. Spatial experience and green building, to me, they are no different. Same thing as indoor environmental quality, and same thing as the well-being. We wanted to improve the well-being of people. Spatial experience can impact the dwellers' well-being in the space. And to me, architecture and interior, in terms of designers, there are no difference. And you have an impact since the layout right through the building elements. And one thing to note, with all those senses that I'm trying to ask you to separate it, but we sense everything at the same time. all the 4 or 5 at the same time. And once we sense these 4 or 5, our brain interprets it as a delight. So if the space is going to be delightful or not, you can judge it at that moment. So sometimes we think about this space. This is an office that passed the LEED requirement, good for daylight. But how about acoustic? Usually LEED building has been complained by having a bad acoustic because people don't have privacy when they talk on the phone. Because to enhance daylight, you have to lower the partitions, or sometimes no partitions at all. So if you sense everything at the same time, we could be doing or designing our space integratively. Secondly, you actually sense everything through time, meaning not just at the one moment that you perceive space, but you keep on perceiving it until it creates an experience of space. That timeline can be daily as an office worker, and that timeline can also be seasonally or annually as one experiences the space. This is an example of a typical office space we find in Thailand. You'll see that it may not look as nice as in the renderings. You have some sunlight penetration because this is a fully glazed window on the west side of the building using clear glass. And you'll see that lady there. We don't see her face clearly. This is actually what happened. I just want to point out that this is not one designer, but it becomes a typical design that when I say architectural design actually impacts interior, spatial experience. So note that. So I would like us, especially the newer generations of designers, to rethink our design process. Can we rethink when we create our space? How do we experience various senses during design phase? Because we don't actually have a completed building. So one thing our company do is we have a design process that we call GRID, Green Research Integrated Design. What we do is that we try to integrate green design considerations throughout all the design process. So it all is involved in the design process, using environmental analysis or simulations throughout the process so that we can probably sense our space in advance before it gets built. So what we try to do is that if you look at the dash line along the design process, we usually spend time more at later phases of design. But integrated design process, we wanted to push more of our effort during early design stages, trying to sense our space beforehand so that we could remedy it before it actually happens. What we do is that we use green building performance simulation, so use various simulation tools to verify and develop design ideas along the design process. That's what I call sensual experience tester. You could test it before it happens. May not be all, but at least we're trying to do so. So process-wise, I'll go through this very, very quickly to show you. I'm only talking about process, not end product, but how we can rethink our process to change our end product to a better spatial experience for the dwellers. First, if we know what the climate is like, there's differences in different locality. Site context is different. If we know that I'm in a hot and humid space, but if I zoom down at the site level, I may have some of the shades. It may not all the way get too hot. What about the winds? We know that each country has prevailing wind direction. But once you live in an urban environment, does the wind actually come from that direction at your site? Probably not. We have the tools to verify that. If you wanted to punch a window at certain location to generate fresh air, how can you be sure that the wind actually gets through? We use this simulation to test beforehand that this can actually be okay. Massing configurations can also be tested for the shading to ensure that our design, as we conceptualize, design ideas can actually work. If I said I'm going to raise a mass up so that it would shade the other building, how much would it actually shade that next building that I'm designing? We have the tools to test for that. Once I have this L-shaped configuration here, what is its impact throughout the season? Does it generate different shadow patterns because the sun actually moves throughout the year? It doesn't stay still. It moves in a different path during equinox, winter, and summer. How does that impact your design? How does your design impact the site? What about heat? Thermal sensation. If you said that you are going to bring the wind from one location, do you know how much sun or how much it gets hot or cold at your site? If you have that information beforehand, if you know the impact of the massing on the site, how much shade it's going to generate, how much help it can do to you to help reduce the unwanted heat, you might probably be able to design to respond to that better. And on the lower image, building skin itself, if you know that there are a certain portion of the skin that receives a lot of heat, is there any treatment or any design that you can do? I have this rendering here. In general, especially for students, we use renderings to communicate our design. And with this rendering is what I call 3D photoshopping, meaning it is Photoshop because all the renders look nice. But does the light actually be in that direction at your building site at the time that you want? How can you be sure? This is what I call visualization, but not really actually sensing the space. This one, the building seems to have a lot of horizontal shading, but how can you be sure that it stays there at the correct orientation? Can it block direct sun angles or not? When I punch that hole on the ground floor, raise it up so that prevailing wind can enter, I can use simulations to ensure that that's where the wind is going to come from. And I can ensure that the pool in the center will be shaded by that building mass through simulations beforehand. By using solar rays testing, we can optimize building skin design. And with this different operation of the building skin and the design, with simulations tested, you can be sure that at each operation of it, I can use the same modules of shading, and it blocks the sun at different orientation of my building. So we would know that by just having this rendering, but behind that renderings that we see, we know that the space is going to actually work, is going to be shaded as that. We'll have to await the actual, when people actually experience the space for a long time, so to see. But at least we have a tool, we have a process to rethink and to sense beforehand how the space can perform. Even with this shading, optimization, daylighting simulation, tested, we even can test the shadow so that the landscape would know where they would place different kinds of tree, and different trees generate different shading form. We would know that this diagrams is not just magic arrows drawing, but all these arrows has been verified that the wind is actually going to come that way, that the sun is actually at that direction, and the shading is going to protect it. So I would like to emphasize, especially for the younger designers, that not only talking about products, but we can rethink our design process to help enhance the user's spatial experience so that they can dwell in the space comfortably and delightfully. Thank you very much.